out live stream. So, hey, welcome everybody. It's 2 hours UTC, and it's time once again for Astronomy Daily Live. So, hope everybody's doing well out there in the universe and the world. I'm wondering if this camera's a little. Yeah, well, just like everything else, it's a little bit off. So, that's all right. That's all right. So, yeah, well, hope everybody's doing well. I was just mentioning to Atta that I think this is we're gonna nerd out a little bit on one thing in particular. But you know, we'll see how it goes. I've always got things in my back pocket, all right, that I can just let's do this. But let me look at the chat, make sure that the chat is going good. Tom, hey, Ray, nice to see you there in the chat again. Well, all right, I'm not going to continue blathering on. I'm going to say howdy to Atta. Hey.
Hi, everyone. I want to tell you, I got a chance to get out. I saw Jupiter. Hey, that's no big deal to you guys, but it is to me.
No, that's a huge deal.
The moon, and I really saw it clearly, which was nice.
Yes.
Like I said.
So did you see any kind of detail on the planet itself, like any of the equatorial bands or?
Oh, yeah.
Yeah.
That's what was so great. I mean, I've seen Jupiter before, and it was just kind of fuzzy.
Right.
But this time I could really see it
with
clarity.
Good.
I was so thrilled. Oh, God.
Set your faces on the you're going to beam directly into the capital city. Alert status.
I heard some kind of weird noise. I guess we'll just ignore it. So
that's me.
Bobby, hey, what's going on?
Yeah. Sorry, I had a little trouble connecting to the panel. I missed the ending part of the show when they do like the waterfall and stuff because everything just went south.
Oh.
Well, oftentimes if you don't go south, you don't know north. So you've got to endure. And Bobby, I know that you will endure. So good. Well, yeah. So Atta's back. You see that? She looked at Jupiter. Was it last night or the night before, or both?
Both.
Nice.
It was so great.
Jupiter and what?
To actually get a chance to view 2 nights in a row, I almost.
Yeah, but Jupiter and what?
Almost and the moons around it. And I spent just most of my time looking at Jupiter. I was out there for so long. I had to bring my backup battery with me. I mean, I've got this big lithium cadmium 10 hours worth of stuff. Even the built-in battery on my Next Star Evolution lasts for a while, but I have a lot of stuff hooked up to it now. I have the automatic focuser. I have the GPS unit. I've got a whole lot of things plugged into that battery. So it only lasts maybe 2-3 hours.
Yeah. I mean, it's probably pulling 2 or 3 amps maybe or so. And if your battery is like a 10 amp hour battery, you've got your 3 hours right there. So,
but I have another battery that I can hook in.
Yeah,
battery. I can stay out there forever.
What you're describing is at least exactly what my 12-year-old, 13-year-old eyes did as well. I would spend hours just looking at, one thing because it was just so incredible.
Well, for me it is. I am at a 12 or 13-year-old level in my progress, so I'm having the same reaction a kid would have.
Well, plus, I mean, it sort of sounds like you had some really, really good seeing conditions too. So
They didn't last long. They came in and out, but when they were there, they were excellent.
Yes.
It was like that. Was moving.
Yeah. You received a wonderful gift there.
Yes.
Because
I sacrificed one of the old people to the god of the sky for this.
Hey, whatever it takes.
I have a big population to select from here.
Yeah. Actually, now that Jupiter is past the opposition, it's going to be in the evening skies now, all night long for a while. And I was looking at an old project that I sort of started back in 2014 or so. And it was under really, really, really difficult conditions, but I was able to get some really, really good data, and I was looking at that data today, and going, man, I should really think about finishing that, because what I want to do is I want to look at the light curves of those 4 Galilean moons of Jupiter as they go around. Since they're tidally locked, their faces always face Jupiter. So as they go around the planet, we see all sides of it. One revolution is actually one rotation as well. And I think that knowing what I know now about that thing working pretty darn well, I think that I should be able to actually get a light curve of those moons. And I guess I still have to, and this is sort of why I stopped before. It was sort of like, well, to what end? Why am I doing this? Am I just collecting data?
Yeah.
Is that enough? I don't know.
So you introduced to Tom, only Tom, Ray, and there's Chuck in the chat. And also, you could have told that on the panel. If this guy dude gets here, tell him I saw Jupiter. He made a movie of it.
Yeah. I was so thrilled that I was able to see, oh God, I wish I knew how to use my camera.
And may I give you a good review of that lunch today?
Okay.
You want to give a review of the Falcon 9 launch? Is that what you're saying, Bobby?
Yes.
Proceed.
Okay.
Proceed.
So, one of the things I never knew about the launch in California is it's very common, typical to have that ground fog and not cause any form of technical issues. I mean, you couldn't see the launch pad or anything, but when they started that rocket, you could see the fire from the rocket just blasting you into your eyes, and as they go up, and then by the time it reached about maybe 10, 100, like about maybe 10, I don't know how high it is in kilometers and stuff, but when it finally get out of that fog, you could definitely see the rocket.
That was great, right? It popped out of the fog. Yeah.
Yes. And what's also good about it is I love the way how they everything was peachy. The landing was right on the spot.
It was perfect.
Yes.
Even in the fog. That's because they don't need to see that way. They use radar, GPS, all of that. So they don't have to see. They don't have to see.
And it's automatic, right? Or they have someone to steer it.
No, it is definitely in a pre-programmed path. And what they actually do is they actually, they calculate a path, and then they watch it. They actually collect the data and see how close it matches that path. It's never exact, but yeah, it is a fully planned thing. Nobody is steering.
Okay.
But
so may I continue?
Well, let me explain one more thing.
Okay.
Somebody does have their hand on the destruct button, right? So if there's any kind of problem, bam.
It's just more fireworks.
All right, Bobby.
Okay. So like one of the things is like when they send those 3 satellites in the WOW. The first two you can see, but the last one, I think I'm not sure if it was deliberate to not have a video feed for it, but everything was just fine and stuff.
Yeah, I think they've only got maybe one camera inside of the payload fairing, so they may not be able to see everything. So, warp factor 1, Captain. So yeah, and actually I didn't stick around to watch the deployment, but I did hear that it went well. So that was great, and it was really pretty to see that sort of blasting out of the fog.
And do you still have your shortwave radio?
Mm-hmm. I do.
You should try tuning to 9330 kilohertz after the show if it's still on. Maybe check it out with this in my Sanjan antenna. I can do that.
All right, cool. All right, well, the thing that there he goes.
And it's broadcasting World Radio right now, which is pretty darn brilliant.
Oh, very cool. Very cool. All right. Well, anyway, so I thought that what we could try to do tonight is sort of nerd out a little bit.
Nerd out.
Yeah.
Nerd out.
Let's do it.
Nerd out.
He's just way ahead of me today. Totally way ahead of me. Dang, I got to catch up. All right. So what was it? Maybe a week ago, maybe even longer. There was this asteroid that passed by Earth. It did a near pass, and it doesn't have like any kind of a proper name, but it's designated as 1999 KW4, and it's like a 1.4 kilometer, about a mile diameter asteroid that did a near pass. It got I think about like 3 million miles or so away. So not incredibly close, but I thought that it would probably be bright enough to actually see. And so I went to the ephemeris and I looked, and it's like, well, yeah, it's supposed to be magnitude 12.5. And so I'm thinking, with a 2-second exposure, 3-second exposure, I might be able to grab those. Are there shenanigans in the right? Be careful with that, Tom. You never quite know what's going to happen if you continue that.
Yeah. Yeah, for sure. You may never know if you're trying to launch the nukes or whatever, or trying to blow up North Korea.
Mm-hmm. Anyway, so I was out there looking at this as well, and I had two problems. The first problem is that it took me way too long to find it, way too long. I I like to be able to find things in maybe 5 minutes or less, 10 minutes or less. This took me 20 minutes to find it. 20 minutes.
Wow.
And
does that always make you tick you off when you just got the furniture charts only to get back to differ?
Oh, it just drives me insane. It just drives me absolutely insane. This, but I really wanted to have a chance with this target because it's so unusual, because it's moving so incredibly fast. It's moving really, really fast. It was moving about 1 arc second per second. So a 5-second exposure would actually make a short little streak, which is no good. So I had to limit myself a little bit, to shorter exposures, 2-second exposures in this case, and because it was moving, what I was seeing on my chart and what I was seeing on the screen were, that object was moving through that field, and it was confusing me, right? Totally confusing me. So it just took twice as long as what I wanted to. And by the time I got on it and locked on, and things were looking good, all of a sudden it just got darker and darker and darker and darker. And I looked up, and the telescope was pointing right at my house. So that thing had set, right? It had just set behind my house. So I got, I think I got 85 total images. And I don't know if there's anything that I can sort of keep. It looks pretty terrible, but I want to show you anyway, right? Because, I have no shame.
Before you do that, did you not know that on your shortwave, tuned to 5125 kilohertz, either with AM or upper sideband, and you'll be able to listen to your SIBO testing?
Oh, very cool. Very cool. You're talking about the radio observatory in Puerto Rico, right?
Yes. Yeah. Yes.
So what are they doing with that?
They're doing the same thing like HARP always does every once in a while, is trying to heat up the ionosphere.
Yeah. They're trying to do interesting things. Yeah. Anyway, okay. All right. Well, cool. So, what I should do first, like I said, I'll show you some images. Now, these images that I'm going to show you, I think I'll show you the reduced data. So that is the raw data that I have dark subtracted and flat field. So it's nice data quality stuff. So let's see. Let me make sure that DS9 is up and running. It is. Okay, so I'm going to share my screen, and so we're probably going to have to do that, but that's okay. Well,
yeah, I think the RC will stop for tonight.
Okay. Okay, so I'm going to do that, and then I'm going to put this over here because maybe we'll use that. But this is what I wanted to actually pull up here is DS9. I can make that a little bit bigger, I think. There we go.
Yeah, baby.
Okay, so let's. So these names aren't going to make much sense to you, but let's go. Let's look at this one.
You know what's kind of a bit weird with Tom's comment is I know sequence 1 and 2 in the initialization code, but I don't remember the third sequence 3.
I don't.
Yeah,
Oh,
remember
yeah.
Tom's comment?
I'm not going to tell you. No way. You never know what's going to happen. Anyway, so here's actually probably the best image I got. And so what you're seeing here is sort of 3 objects and what sort of looks like maybe a cosmic ray up here. Nothing else, right? Just sort of these 3 things. And this guy right here is the asteroid. That one right there.
Oh.
So that's the asteroid. Oh, let me recenter that. And it passed by these 2 stars. So, like I said, this. Oh, Page Master just spilled it. Look at that. I don't know.
0.
0, 0, 0. Destruct.
0.
Oh man. Now you've done it.
Page Master knows everything.
He does. Those kind of people just drive me crazy.
It's really upsetting.
It's really upsetting. Okay, so
we just nuke the stream.
So this is actually, I would say, the best image I actually got. The asteroid itself sort of made its way this way really, really fast. Here, I'll show you another one. Now, these aren't going to be lined up or anything, but let's put it in a new frame here. Which one was that? That was, how do we get back to the other? Oh, this way. So that's 42. Let's look at something a little bit after that. Let's go to, I don't know, 75. Okay, so this one isn't quite as easy to see, but there it is right there. All right, so this is going to hurt a little bit, but if I sort of blink between those, yeah, that's kind of hard to pick out. Let me not blink. So here it is here, right? Right. Some fainter.
I think I kind of agree with Autumn. Always thinking about destruction.
just blow it up. You bet.
But let us evacuate, please.
Yeah. And here it is there, right? And so, as you can see, this is actually pretty bright here, but it's just, for whatever reason. But you can sort of see how much it's moved. So it's gone from way down here to way up here in wow, that's got to be just a couple of minutes. 75 to 42. 75 minus 42. And let's see, I think I'm downloading those in about maybe 6 seconds or so.
That may not be a huge asteroid, but a mile across is still a respectable size. I wouldn't want to run into it in a dark night.
No, definitely not. So, sad to say, I really don't have a lot of data here. And what I do have is pretty terrible. So, Symphony of Destruction. That's funny. I have no idea, Ray.
I don't even listen to metal.
No, I don't have any idea either. That's a musical genre that I never got into.
Fascinating.
Extremely. So, I'm still trying to decide what I've learned about this particular exercise, it's to have an object that bright accessible to a small system like what I have is pretty rare. It's pretty rare. So yeah, I don't know if I'll ever have another chance to do that, but it was kind of neat, and it was really, really amazing to see how fast this thing was moving. I have never seen a celestial object move that fast. It was super fast. So it was nice to see, but yeah, I've got to think about how I could improve on all of that, because yeah, I mean, I wouldn't call it a total fail, but yeah, it was more or less a fail, which is okay. Failure is part of the plan. That's science. So, Sound of Music, yeah. Countdown to Extinction. Man, yeah. As soon as I hit college at the end of the 80s, I was on such a rocket. I was on the astronomy rocket, and I don't remember the 90s. I don't remember them at all, because I was riding the rocket. Very cool.
What kind of genres were you in the 80s? And
what kind of what?
What kind of music you was in the 80s?
Oh, we liked Pink Floyd was good. I liked I don't know. You've caught me off guard. So I'd have to think about that a little bit. But Journey was really, really good. I'm trying to think of a few others. There's the Police. Police were absolutely fantastic. ZZ Top, I really like them. They're sort of a really, really nice blues band. Yeah, I'm trying to think of others. I mean, I liked all the like the electronic stuff. So Pet Shop Boys was really cool. I'm trying to think of others. There were a lot. I would have to look at a list. But anyway, let's maybe look at one more image here that I got. Let's sort of maybe look earlier.
You're going to have fun in, what is it, 2029 when Apophis comes around?
Yeah, I can't wait.
Oh, yeah, neither can I. I hope I'm around when Apophis comes around. Don't know.
Yeah.
Not too likely.
They say that it's going to happen in 2012, but we got beg to differ.
Yeah, it's 2029.
Yeah. Well, if it happened in 2012, we missed it.
Yeah.
So I think this is actually it here, but it was moving so fast. This is a different field of view. As you can see, there's a bright star here. I think that one might be that one, but I think that's the asteroid there. And yeah, it's really it's not very good. I need to think about this a little bit more, to see if there is anything I can do with this. Maybe astrometry, maybe measuring the position of this. Yeah, I don't know. There just isn't a lot there, and it's pretty crummy.
Yeah.
So yeah. But what I thought.
And those that predicts when it's going to be the end of the world are just hypocrites.
Well, I think most of them think that they're right, but
because look at Y2K. We survived Y2K. We survived 2012, and now they're saying 2029. Some people
sooner or later, one of them is going to be right.
Sooner or later, one of them is going to be right. That's right.
What's weird about it is when we think about is you don't know when the rapture is going to come. It could be today. It could be tomorrow.
Sure.
Exactly.
It could be about 5 years. You don't know.
No.
You don't know when it happened.
Nope.
No.
Not at all. And that's
why I say anybody that predict when it's going to be the end of the world are just hypocrites.
Yeah. Well, like I said, they probably are pretty sure. They have convinced themselves in some way, and that's okay. They can think whatever they want. It's not totally just on them, that everybody's fooled, right? So I don't know. Yeah. Anyway, what I thought that we could do is actually go over to the JPL Horizons website and pull some data and look at the passing of this asteroid in sort of a couple of different ways. And so what I thought I would do is grab the orbit of this asteroid, maybe for like a year, do like a year.
Never heard of GPS Y2K happening at April 6th this year. Never heard about that.
Oh yeah, that was another one. It was I don't remember exactly what the circumstances were, but yeah, I saw something about that, and yeah, it had to do with I don't remember, but yeah, that was averted too because people fixed the problem. So anyway, I think the time span is going to be a year. So here we are back on the
And Baby
JPL.
Ray, what else say is true. The end of the world comes for me when my time here ends.
Absolutely. Absolutely. When your number's called, you go. All right. So this is a really, really great site. You can find out all kinds of useful information about pretty much every solar system object, including moons, asteroids, satellites, rocket bodies, planets, comets, pretty much anything. And it's the kind of information that you can get here is extensive. So I'll sort of go through a little bit of this because, yeah, I think we looked at this, I don't know, a couple of months ago. I'm not exactly sure, but I like to come back to these, from time to time. So this ephemeris type is just an observer type. So I've got it set such that it just sort of, prints out astronomical observation type of information. There is also this thing called a vector table. And in this particular case, that is the option that I'm going to use, because what I want is I want some XYZ numbers. And those numbers are actually going to represent distances between the sun and this asteroid, and also the distance between the sun and the Earth. So we're going to have two different data sets. And then what I'm simply going to do is subtract the distance, the Earth-Sun distance from the Earth asteroid distance, and that will give us the distance between the Earth and the asteroid. And once we know the distance, we can sort of, press the play button and look at its velocity and acceleration and all those higher order terms. So let's do it.
Not me. Not me.
Not me. I don't think it's me either. We got to blame Atta.
I shut off my mic.
Okay.
I did it. You won't hear it anymore.
So let's do the asteroid first. So I happen to know what number it is too. It's 66391. So there it is, 1999 KW4. The origin is going to be the sun. Now this is saying the barycenter. I'm going to change that to, let's see if we can. Let's come down here.
So Ray is. We're gonna say goodbye to Ray.
You take care of yourself, Ray.
Take care, Ray. Hope everything goes well.
He had a stress test today and 2 other tests in the morning. Didn't sleep good. He's wearing a cardio monitor until tomorrow.
Okay. Cool. Cool. All right, Ray. Well, take care, and hope everything goes well. You gotta make sure that the ticker is ticking well. So you hang in there, get through all your tests. I hope you pass them.
Yeah.
All right,
because I think I'm so lucky, even though I got a sludge in my gallbladder, that I can still kick some butt.
I believe you. I totally believe you. Okay, so
the medicines that I take will not only damage my liver, but also do some damage to my gallbladder. And another one that I take will diabetes will run in the family, but I'm so lucky that I've yet to have diabetes.
Yeah. Well, and
one of the medicines I take can get me diabetes.
Cool. Yeah, interesting. Yeah, and diet can really help, with diabetes too. So for sure.
Yeah.
So okay, well here we are. So we've got the sun, the center of that body. So right in the center of the sun. Let's do this time span such that it passes the closest approach. Because I want to see sort of how fast it was moving relative to the sun and relative to the Earth. We'll be able to find both of those out. So let's see. I think the closest approach was something like May 25th. So why don't we go back to, why don't we do 2018 November 25th? Because that is 6 months before. And we'll go to 2019 11/25, like that. And since this is a year, I don't think I want the step size to be one minute. That seems a little extreme. Oh, we got a doggy alert. Let's do hours, because let's see. I've pulled out my handy dandy calculator here. 365 times 24. So that's 8,760 data points. That'll be nice. That'll make some nice smooth curves. So let's choose hours. Okay, so I'm going to get data on this XYZ distances from the sun to this asteroid over the course of the year. Warp factor at least 1. At least 1. Okay, so all right, let's see what the table settings are here. This is when it starts getting complicated. So here's your types up here, and I think really it's all I want is just the position. So just XYZ. I'll worry about everything else. But as you can see, there's lots of there's tons of options here. Yeah, but let's choose that one. The output units, astronomical units. Let's make that kilometers. Let's go kilometers per second in terms of velocity too. Okay, let's do that. I'm just going to keep these exactly the same. So when we do a difference between them, all most of the stuff is going to sort of cancel out. I definitely want it in a comma separated variable format. I think I'm gonna leave everything else just as it is. I don't really care. I don't think I care. Okay, so we use those settings. And then the output, we'll just do plain text. That's the best way to do it. So, all right, well, let's generate this ephemeris. And, there's going to be almost 9,000 lines here, but we'll see what it looks like. So right at the beginning, they have sort of all the orbital information about this object. So, this is all of that. I don't know all of these things. I think inclination is probably that. I think I don't know if A or if it's Q. I think it's Q is the aphelion, so distance in astronomical units. So yeah, all these numbers go into a calculation to get the orbit. But anyway, we sort of move down here, and here we go. I'm going to zoom out just a little tiny bit, trying to get all that to fit. Whoop. Okay. So what this is showing, this is the Julian date. Mm-hmm. Here's the calendar date. Here's the time. And then here's the X, Y, and Z distance in kilometers.
I have a question.
Yep.
Do you think there's a way to download that type of CSV and then you can just have it on the spot so when you do your canoe plot, it'll be ready to go?
Well, you actually can sort of automate this. I have never had a need to, so I haven't really looked at that all that much. But when you automate it, you get all the results in an email. But I find, just doing a copy and a paste here works just fine. So as you can see, it's
Control C, open your editor, Control B, and save it.
Yep, that's it. That's exactly what I'm going to do. So yeah, changes by the hour, and it goes from November 25th, 2018, all the way to the end, 25th of 19. So there it all is. It's all there. So I'm going to do a Control A, and actually I'm going to do it this way if I can. Is it going to let me? Oh, it's trying. Uh-oh, it's the old potato.
Oh my gosh.
I don't know what it's doing. I've just overwhelmed it with almost 9,000 lines of text, heavy text. So I'm hoping that this.
I don't think your right might work.
No, it's completely frozen. All of my Chrome is frozen.
What kind of computer do you have? What kind are you using?
This is a, I think it's a Dell Optiplex 330. It's old.
No, I was just thinking in terms of the CPU and the memory and that kind of
stuff. Yeah. You know, I think this is, again, I think this is old. I think this is like a, I think it might have a dual core.
Maybe. Oh my God, dual core processor?
Jeez, maybe, yeah.
That's a credit to you. You can keep that thing running, today's software.
It is absolutely incredible. I am completely amazed myself.
But I think those types of computers are usually either in the Vista or XP days.
Okay.
Probably, yeah. I think this was an XP before it turned into a Linux. Oh, it looks like I've got it back. So I'm going to try that again. And I should be able to go over here and do it like this. Whoop. So I'm going to actually put this somewhere else. Live. I'm going to do 613. Okay, so let's put it here. So we'll just call it KW4.CSV. Bam. So that'll take a minute or two. We can watch the dates roll by. These are dates that have already happened. So here comes last Christmas coming up here. Oh, there it is.
And very last day, you give it delay.
It's what everybody's come here to see is scrolling numbers. What great excitement. Okay, well, you know, I think while that's going, we can actually grab the one for Earth. So that is the other one that we want. And I think I can just do Earth. Oh, search failed. Oh, sun and planets. Here we go. How about Earth? Geocenter. Thank you.
Why not?
Okay, so for exactly the same dates, exactly the same everything, except it's now Earth. There's that one. And let's see how this guy is doing over here. Oh, he's still going. What I'm going to do is I'm going to shut down DS9. That'll help. The old potato. And well, we're into April, so we've almost caught up to the current date. You can sort of see these numbers change. So right now, what X is about 70 million kilometers. Y is about 140 million. And Z is like 8 million. So these are
how they can calculate a Julian date.
Well, that's actually sort of a complicated thing, but it can be done. It can be done, and yeah, you know, most astronomers sort of as a formalism almost always use Julian date. That's not always true, but that's sort of the accepted astronomical time.
Oh no! How far?
Enterprise, come in. Kirk to Enterprise.
Kirk to Enterprise. What was that, Bobby?
right, so, like, how far you did your infirmities on this one?
How did I what?
How far did you, you said you're supposed to do it for a year. It's going on to September now.
That's right. It should go to November 25th. So we have about a month and a half left. And then we got to do Earth. Lots and lots of numbers. What did I say? Like 8,700 lines. So yeah, you can sort of watch these numbers change and see how it's moving with respect to the sun, which is going to be, some kind of elliptical orbit. Okay, there's that one. So now we'll do the same thing for Earth. Grab all that. And, well, can I do this? Oh, it's going to have a fit. Yeah, it doesn't like me to right click. So, yeah, I did it again. We'll have to pause here and let it figure itself out for a second.
At least you're not glitching as of yet.
Yeah. Here's some pretty interesting info about the Earth itself. I kind of like this about this site. They have this sort of a prefix here that has all kinds of interesting things. Oh, this.
Hey, there it goes.
Yeah. Okay.
There we go.
Fine by me. Here we go.
By me.
So notice right away that the Z distance here is like 3 or 4 orders of magnitude smaller. So the Earth.
Are you gonna go back and try to just get the data points? You don't want any like the prefix and the suffix and stuff.
Yeah, I will. I will go back and actually edit that out. There are ways to skip all of that too, but yeah, it's just easier just to edit it all out. And then what I'm going to do is I'm going to write a little Perl script to do a little bit of this math. We're just going to subtract, the Earth's x from the asteroid's x, and the y and the z exactly the same way. And then that will give us the distance between the Earth and the asteroid. And then we'll see how far we get into this. So this is going into April. All right. Let's see. So yeah, I don't, this is a great site. You could actually get into some graphical things, which are kind of neat too. I thought that there was a way. Earth. Yeah, I'm not sure, but yeah, this is a big site for sure. Just trying to see if I thought that there was an easy way to get into the orbit diagrams, but I guess not. These are kind of neat. So there's where we all are. Yay. Asteroids. You can see the Trojans here, the Jupiter Trojans. There's a concentration here. I don't know if you can see that or not, but here and here. Here and here. So one.
You got good eyes. It's good.
Yeah. I'm sorry for the quality of the video. That's how it goes.
Oh, I can see it.
Yeah. Anyway, and there's a side view. That's kind of neat.
Mm-hmm.
Don't get to see that all that often. Pretty nifty. I'm not quite sure what these white little V's are. Say here anywhere? Oh, a description of these diagrams is given at the bottom of the page. All right. So the inner solar system diagrams show the positions of all numbered asteroids and all numbered comets. Okay, yeah. So these are the little comets. These these guys. Wow, there's lots of comets. Okay.
Wow. They're just ready to just just ready to just come into the sun and get them swing out of the way.
Yeah, yeah. Well, consider the fact that this is just current positions. So they're either on their way out or on their way in. There's a few here that are inside the orbit of Mars. There's only a few. There's like 4. So these are probably the only visible ones. Maybe this one. Yeah. That's kind of cool. Let's see if this thing is done. It's done. All right. All right, so I'm going to get rid of a few of these lines, as Bobby mentioned. Get rid of the beginning and the end, like that. Let's do the same thing here. Have to sing the deleting music. Okay, so there should be the same number in each one. 8761. Yay. Okay. Well, let's go ahead and, what we can do first is just plot these as is. They're just going to be ellipses, but yeah, let's take a look anyway.
Why not? And I just got her cooking the base on.
Good.
Oh, she's decloaked. Ready to proton torpedoes.
Oh, man. All right, so let's look here. We're going to just look at Earth. So this is column 1. Here's column 2. So 3, 4, and 5. Okay.
1, 2, 3, 4, 5. 1, 5.
Let's do a 3D plot. So S plot. Oh, bad typing day. Here we go.
Set your face down. We're going to beam directly into the capital city. Alert staff.
Yes. Using 3, 4, 5. Width doesn't really matter. Let's do lines. One with one curve. So it's just going to be an ellipse. Well, I guess not. No, I guess it's not exactly going to be an ellipse. That's right. It's going to be a wiggly ellipse.
When we first got the window into play, it looks like it was sinusoidal.
Yeah, it did. It was just the angle. But so there it is.
Mm-hmm.
And I'll bet that there are about 13 of these wiggles. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Maybe there's a couple here. I'm not sure. So what we're seeing, of course, is the tug on the Earth by the moon.
Mm-hmm.
So as the moon goes around the Earth, pulls it around a little bit, and that's going to translate into a changing distance between the Earth and the Sun. And you can also see that these two don't meet up either.
Yeah.
So it's a little bit off. Right? It's a little bit off.
Not that bad.
No, not that bad at all. The really interesting thing, I think, is how incredibly flat this actually is. If you look at the numbers here, these are in the hundreds of millions of kilometers.
Mm-hmm.
These are in thousands of kilometers. so you know, your new plot scales these things in an automatic way, but I can tell it to actually scale however I want. So let's do, let's go from negative 200 million to positive 200 million all the way around, X, Y, and Z. Okay, let's do that. Negative 2E8, 2E8, like that. 2E8, 2E8, and we'll do it for Z as well. 2E8, 2E8. Bam. So now you'll notice that you can't see any of the wiggle anymore.
Yeah.
Because it is incredibly flat.
Oh my
See
God.
that?
Jeez.
Like a, man. Good enough for a pile chopper to go through.
Yeah. I mean, it's a very, very flat orbit. But if you look at the details, all those wiggles are in there. It's just, you know, using this scale, there's you know, just no way to do it. So let's do exactly the same thing for our asteroid. Should be the same format and everything. So, and I'm just going to let this auto scale. Now this, I predict, and sometimes I'm right and sometimes I'm wrong. I predict that this is going to be a pretty smooth ellipse because there's nothing that's going to be around it to perturb it per se. However, you know, this asteroid is known to have a moon. So I don't know. I don't know if they've incorporated that into these calculations or not. And of course, you know, these are calculations. These are not observations. These are calculated positions. So let's see. Oh, that looks pretty smooth. But it's kind of hard to tell because the scale is really, really big here because, you know, the inclination of this thing was something like 38 degrees or so. So yeah, I mean, it's going to go way, way far out of the ecliptic. So there that is. I don't know if there's any way that we can, I guess the only way to see if there's any kind of higher order wiggling or anything is maybe look at the individual X, Y, and Z versus Julian date. So we can do that. Let's just take the X axis and the Julian date here and see if we can see any higher order wiggling as opposed to just a sine wave. This should just be a sine wave. Or two sine waves. How about that? So again, yeah, it's kind of hard to tell because of the scaling. So yeah, that's not going to work. Let's do this. Let's look at this portion right here. So I think if I go from -7 to -8, that'll include that. So let's do that. It's along the y-axis. So -8. Oh, what were the E7? E7 to -7. E7. Well, maybe we should stretch this out a little bit too. Let's go. Oh, this is getting tricky. Whoop. Let's see here. Let's go 45855. 245. 45. Oh man. 45855. I think there's another 0 there too. Oh, I don't know if that's going to work then. 686. 458. 645. 865. So if we go 65 here, I think 65. So that, I don't know if that's gonna. Okay. Yeah, I'm not seeing any kind of wiggling in there. I don't know if we would see it at this scale or not, but I'm not going to try too hard. Let's see. So let's get back to that. Okay, so there's that guy. So now what I really wanted to do was I wanted to subtract these two, and maybe we'll end it on that, because I'll be able to do this really quick. And please forgive my relatively poor Perl programming skills. I'm just going to do it really quick here. Just do it like that. So that just means it's going to grab what's coming in from what's called standard input. So we'll do it like this. I'm going to split these by commas. The input, commas, and x of I is going to equal a of, I don't remember what it was. The x column is 0, 1, 2. So 0, 1, 2. Y, Z. I just love my naming conventions, don't you?
Most illogical.
Who's asking you? Let's see. I need this, that, semicolons. Oh, you know what? I need to do this a different way. Open. I need to do this a different way. I can't do it from standard input. I need to do it this way.
Captain, I suggest Falcon mind probe.
Yes, please. Any help I can get. Especially since I'm going a little fast. So, all right, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And there's going to be 2 of these. Well, there's going to be that. And there's going to be that. We're going to call it Earth and AST. AST for asteroid. AST. And this is going to go here. Bobby is multitasking. He's listening to shortwave and making sure that my Perl is right.
I don't know. I'm not a good programmer. I never did programming.
Don't do it. It's habit forming. I think I've got all that right. J, yeah. Okay, so now we're going to do this. We'll call it M. It doesn't matter what it's called. Less than J. like that, and I'll even spell it out. So we're going to go Earth minus asteroid. Right? And let's see, this is, let's call that X diff like that. Y, Z, whoop, Z. And we're going to do all this. When you're a programmer, you learn to type very fast. I think that's it. I think that's it. We should probably, well, we'll do this for now. And then if we want to look at this again ever, we can change things. Okay? So I'm going to read all that in. I'm going to subtract the Earth's XYZ from the asteroid's XYZ, and then I'm just going to print the differences out. That's it. Simple as that. I think I've got all that right. We'll find out. Just let's call it Earth and KW4, and we will output that to output. Oh, it did something. Ooh, there's numbers there. Lots of numbers. 8,761 of them. That's exactly how many there's supposed to be. Oh, well, I think maybe we did it. Let's plot them. Let's see what it looks like. I have no idea. I have no idea what that is going to look like. But we are going to find out. Using 1, 2, 3. With lines, line width, line color 8, which is black. Here we go. I have no idea what to expect. No, I really don't. Huh. All right.
It looks like to me you made a 3D heart, baby.
There we go. Yeah. Interesting. Interesting. So, you know, all these numbers here are in kilometers. So these are some pretty big numbers. 350 million kilometers.
Energize.
So yeah, this is just the distance between the Earth and that asteroid over the course of a year. And as you can see, something really interesting is happening right about there. See that?
Mm-hmm.
It sort of looks like it is coinciding at least with this X and Y. I'm not quite sure which one is X and which one is Y, but these numbers come pretty darn close. So I would expect that this is when the closest approach occurred. Let's we can look at just the X values, see what they're doing. Whoop. I have to do one more thing here. See, I knew that I was going to get into this, and I want to do one more thing, which is the I want to save the Julian date. That's the first one. And then we can put it down here, like that.
Enterprise. Enterprise, come in. Kirk to Enterprise.
Jim, get off while you can. Okay, so there now on the left there is the Julian date. So now we can go back here. And we can do that. So that's how the X distance changed over the course of a year. And yeah, you know, 0 point is right about there or so, which is yeah, like halfway in between our two dates. So that makes sense. So that's the X distance. Here's the Y distance. Look at it the same way. Kind of interesting that the Y distance, at least right now, right, isn't really changing all that much. I have to think about that a little bit. The Z distance. The Z distance is just doing its thing there. And when you put it all together, oh, now I've got to do 2, 3, 4. You get that. Pretty cool. I'd sort of be interested in running this for, you know, like 20 years or 30 years, and see how this thing sort of changes. It might be interesting to do that. But I am looking at the time, and it is late. It is late. And, you know, I don't want anybody turning into a pumpkin on my watch. So I think for now, I am going to get on out of here. Let's see if, yeah, don't see anything else in the chat. Good. So yeah, I think I'm going to get out of here for now. I'm going to play with that a little bit. Maybe we'll play with it a little bit more tomorrow too. Don't know. But yeah, I think it is time for us to go. So have a great evening, a great day. Thumbs up if you so desire. Live long and prosper. And I'll be back here again tomorrow, 2 hours UTC, more astronomical things. Maybe, you know, we'll nerd out a little bit more. Who knows? Maybe do some art too. Who knows? All right, everybody. Take care. I will see you